Welcome to the video lecture on VLSI design. This is for the academic year 2024-25 and offered for the 2024 scheme students. And the course code is BEC 603 and the CAE marks, continuous internal evaluation marks, is going to be 50 and the teaching hours per week is 3 hours. The semester and examination marks is going to be 50 marks. However, the examination is conducted for 100 marks. Later, the marks is scaled down to 50. The examination hours is going to be 3 and the total number of contact hours for this particular course is 40 hours. Now, before we move to the more details of the course, let us discuss on the course objectives. The VLSI design course imparts knowledge for the knowledge of MOS transistor theory and CMOS technologies. That means in this course we are going to discuss the MOS transistor theory. MOS stands for metal oxide semiconductor field effect transistor, MOS transistor theory, followed by complementary metal oxide semiconductor field effect transistor technologies. The second objective is to learn the operation principles and analysis of the inverter circuits. The third objective, we are going to discuss on the design of various circuits, namely combinational circuits, sequential circuits, dynamic logic circuits as per the requirements. The fourth objective of the course is which infers the operation of semiconductors, memory circuits. And the last objective is we demonstrate the concept of CMOS testing. Now let us have a look at preamble of this course. VLSI, as we know, it stands as very large scale integration and it is a technology which is the heart of the modern electronics, and this enables the integration of millions of transistors. In today's trend, it's going to be the billions of transistors onto the single chip. This course dwells into the intricacies of VLSI, covering both theoretical and practical aspects, which equips with the knowledge and skills necessary to excel in the domain of VLSI design. This course includes fundamentals of MOS theory, fabrication process, delay calculations, especially within the MOSFET, in the design, prescripts and memory, etc. The course aims to produce VLSI design engineer in the field of electronics engineering. Now let us go through the importance of each module. The module 1 discusses two chapters mainly. First is the introductory chapter, then followed by there is a MOS transistor theory. In the introductory level, we discuss a brief history of the MOSFET, the transistor in general, and evolution of integrated circuits. Followed by we discuss MOS transistor theory with necessary equations, characteristics, etc. Followed by we are going to discuss the complementary metal oxide semiconductor logic. Generally we call CMOS logic. Here we discuss the schematics of inverter, NAND gate, NOR gate and other complex logic circuits. Followed by the first chapter. In the second chapter we have a chapter dedicated for the MOS transistor theory. In this MOS transistor theory, firstly we introduce the transistor basics, transistor fundamentals, followed by long channel, the IV characteristics. I stands for current voltage characteristics, V stands for voltage characteristics. Then we have non-ideal IV character effects, followed by the DC transfer characteristics. So in general, this complete module describes the history of the MOS transistor theory and followed by the current voltage characteristics. And total time reserved for the module 1 is going to be 10 hours. In module 2, we dedicate again for the two important things. One is fabrication, the second one is going to be the MOSFET scaling. The fabrication part mainly deals with the CMOS fabrication. Particularly we discuss how to draw the stick diagram for various schematic circuits. Once the stick diagram is developed, then we will discuss how to prepare the layout for the stick diagram that is denoted, indicated or shown. The layout should follow certain rules, which is called as a design rules or lambda based design rules, what we call, and we'll illustrate here with an examples how to apply design rules for the various schematic circuits or layouts. Then followed by we discuss couple of examples for the layouts. So further we introduce CMOS technologies. So this is a chapter which is mainly discussed about the fabrication. In MOSFET scaling, we mainly discuss two types of scaling: constant field scaling, which is called as a CE scaling, and constant voltage scaling, which is also called as CV scaling. So these are the two types of scaling effects we'll discuss. And also further we extend this chapter to the MOSFET capacitances without any derivations. Once again, the time reserved for this is going to be the 10 hours. The module 3 focuses specifically on the delay estimation and the transistor logic circuits. In particular, we start with the transient response RC delay model and linear delay model and the logical efforts of the paths. So these are the things which are discussed related to the delay. And we also discuss input ordering delay effects, asymmetric gates, skewed gates, pseudo NMOS technology, cascode voltage, switch logic, dynamic logic, and domino logic. These are the various important circuits we are going to discuss in the module 3. Module 4, which focuses on the sequential circuit design. Here we introduce the sequential circuits, the design of particularly on the latches and flip-flops. Followed by we have a dynamic logic circuits. In dynamic logic circuits, we focus on the synchronous dynamic circuit techniques and dynamic CMOS circuit techniques. The total time again reserved for this is going to be 10 hours. The last module of this real course is going to be the semiconductor memories and testing and verification. In semiconductor memories, we discuss about system timing considerations and some commonly used storage or memory elements. Lastly, the testing and verification part includes introduction, followed by the logic verification principles, manufacturing test principles, and design for testability. The total time reserved for module 5 is 10 hours. So let us discuss on the course outcomes. At the end of the course, the students will be able to follow the following course outcomes. The CO1, course outcome 1, which mainly illustrates about understands and which mainly explains about understanding the theory of MOSFET transistors, the flow of CMOS fabrication, the concept of technology scaling, and the principles of stick diagram and layout designs. Course outcome 2, which is mainly the apply, is going to be the phrase here. So we apply the acquired knowledge of combinational and sequential logic circuits along with the layouts to construct the digital circuits. Course outcome 3, here the phrase is going to be the evaluate. So we evaluate the performance and delay of the MOS circuits in VLSI design by analyzing the combinational and sequential logic circuits. Course outcome 4, which is mainly focused on the design. So we design the combinational and sequential logic circuits related to the VLSI design. Course outcome 5, which the phrase is going to be the implement. So here we implement the combinational and sequential logic circuits used for them using the modern tools such as Cadence. So the textbooks prescribed for this course are as follows. There are totally 3 textbooks which are recommended for this course. Among these 3 textbooks, the textbook 2, which mainly covers the 90% of the syllabus, and the remaining 2 textbooks covers the 5% of syllabus. The first textbook is going to be which is authored by Sungmo Kang and Yusuf Liblibisi. Title of the book is CMOS Digital Integrated Circuits Analysis and Design, and the publisher of the book is Tata McGraw, and the edition is 3rd edition 2002. The second book, which is most important and covers the entire nearly 90% of syllabus, which is authored by Neil H.E. Westre and David Moni Harris. The title of the book is CMOS VLSI Design, which is subtitle is Circuits and Systems Perspective. Publisher is Pearson Education. The edition is 4th and is published in the year, reprinted in the year 2011. The last textbook which is required for this particular course is authored by Douglas A. Bucknell and Kamaran Eshrigain. Title of the book is Basic VLSI Design. Prentice Hall of India is the publisher. The 3rd edition is the book is the required textbook, and year of the print is going to be 1994. The students, along with the textbooks that are prescribed, they can also refer to the references for the additional information. The one reference which we have given here is Adel Cedra and Casey Smith, authors. The title of the book is Microelectronic Circuits, Theory and Applications. Publisher is Oxford University Press, 6th edition. and 2009 is the printed year. So these are the textbook required for for this particular course. Students can also go through the alternate assessment methods that we are going to use an assessment method during the course. We'll discuss on this in the upcoming classes. And for the web material, students also can refer this link where huge number of NPTEL videos are also available on YouTube for additional the information related to this particular course. With this, we end up the introductory syllabus, introductory topic. In the next class, we'll start with the MOSFET theory and history of the transistor and integrated circuits. Thank you all.